The Vallorbe Museum conserves all the techniques that were used for the production of precision tools, such as files, as technology advanced. The steel is heated up to a red-hot state in the heart of the forge. The eye of the craftsman determines the precise moment when the metal is ready to be worked by its color. The tang of the file, the part that will be inserted into the handle, is formed first. To hold the file comfortably, the blacksmith inserts the tang into a support. The model for this support dates back to the Roman era. The steel is heated again to form the body and the point of the file. The next step is called annealing. It softens the steel, making it easier to work with. Heated to a high temperature, the blank is cooled down in a bed of ashes. The last operation before cutting is grinding, during which the faces of the blank are flattened on these water-driven grinding mills. Manual cutting is the oldest technology and was already performed in a similar manner at the time of the Celts and the Romans. This worker has mastered the precise movement using a chisel and hammer. The file remains on a lead anvil. The teeth are formed by striking the metal with the chisel. Leonardo da Vinci designed a machine that was intended to replace or even surpass the skilled hand of the craftsman. François-Louis Grobet finally succeeded in building such a machine at Vallorbe. It reproduces the motion of the hammer striking the chisel as the file moves below the striking mechanism. The energy was supplied manually by the worker. It is only at the end of the 19th century that hydraulic-powered machines appeared. Even though the hammer and chisel principle remained the same, it was the hammer and chisel that moved in this case, while the file remained stationary. The sides of the file are also cut, but always by hand. The tool used for this operation is called the raclette. Its tapered sides show the design of the file teeth. By applying pressure and rubbing, this design is imprinted on the softer steel of the file. Here's the tool. You're probably wondering if it's finished. No, not entirely. Its soft material must be hardened so that it can resist up to intensive use on other hard materials. This is called hardening. The steel is heated again and then plunged into a cold bath. The more rapid the cooling, the harder the finished product will be. Each blacksmith had his secret, whether it be special spring water, horse urine, goat blood, or some other exotic concoction. Here, we simply use oil. You can appreciate the finest examples of this impressive know-how everywhere you look at the Vallorbe Museum. Jewelry making, forestry operations, watchmaking, mold making, do-it-yourself activities, sculpture, precision mechanics, scale model making, aeronautics. These are just some of the hundreds of specific activities that require the use of files in thousands of different models. But how are these various tools produced? To simplify matters, we'll follow the course of a typical production line. We're in Vallorbe, at the factory of Les Usines Métallurgiques, installed in large part on an island, which attests to the very long history of this company. Indeed, in the past, the first machines were driven by water power. This is the raw material that will become a file. It is special tool steel. Depending on the section of files that will be produced from it, it arrives in the form of rolls or bars. It is one of these bars that we will follow through the conversion process. The production line is not far from here. But before we take a closer look, Our steel bar must prove that it complies with the standards required from our suppliers. A sample is sent to the lab. It is drenched into bakelite, this black powder. When it is subjected to pressure and heat, the bakelite liquefies and then solidifies around the metal, making it easier to handle. Once it has been flattened and polished, the steel section will be examined under the microscope. What you see on the screen is the core of its internal structure, which is perfect. After it has been approved by the lab, the crude steel can begin the conversion process. The bar is cut up into segments, each of which will become a file. One of the ends of the bar is stamped out to form the tang. Now it's really starting to look like a file. But the structure of the steel is still the same as in the raw material. It is too hard to be easily worked with any degree of accuracy, so we'll need to soften it up. The blanks are therefore sent on a conveyor belt through this tunnel, where a crucial step will be performed known as spheroidizing or annealing. Indeed, the mastery of this thermal treatment is one of the major parameters that guarantees the quality of the future tool. The metal is heated up to 780 degrees centigrade, which gets rid of the lamellar pearlite, and then cooled very slowly while being sheltered from the air. The bars must cool to 550 degrees centigrade while losing only 25 degrees per hour, no more, no less. The flat sides are then ground on a CNC machine under a powerful spray that maintains the blanks at a low temperature. Next comes the cutting of the faces, which will create the teeth to bite the material being filed. The chisel makes a double cross cut. First, on one side, and then the other. Here, in slow motion, you can clearly see that it is this cross-cutting motion that produces the teeth. You'll notice that the formation of the teeth does not generate any metal chips, since the material itself is pushed out and reshaped. The lateral sides are then ground and cut. To give you an idea of the variety of possible cuts, as they are called by professionals, here this rasp has 5 teeth per centimetre, whereas a precision file can have as much as 116 teeth per centimetre. The end of the file without teeth is cut off by the fancifully called caramel cut. Now our file is ready and passes to the essential operation, the hardening. You remember just a short time ago when the steel was softened by cooling it very slowly in the tunnel. Now we need to do just the opposite and harden it so that it will stand up to rough use. The hardening results from a very quick temperature change. The metal is heated in a salt bath up to 900 degrees centigrade. It is then suddenly quenched in a cooling liquid. We then move on to the finishing stage, which begins by sandblasting. The file passes in front of jets of compressed air, water and aluminium oxide, continues through a rinse, and is finally coated with a rust-proofing treatment. Each finished file is then inspected, visually first of all, to make sure that it complies with production drawings. And then it is tested in real conditions and on the same materials used by the final user. Once the file is corresponding to the manufacturer's quality standard, each file is branded as a proof of its origin and quality. Our file is now considered fit to leave Vallorbe for shipment to one of the 100 or so countries in which the order originated. "4,000 varieties of files, representing 723 kilometres of finished products, are shipped out each month from le usine métallurgique de Vallorbe, whom we would like to thank warmly for allowing us to shoot this documentary."